we know that we can find the area of a rectangle by multiplying the base times the height. The area of a rectangle is equal to base times height. In another video, we saw that if we're looking at the area of a parallelogram, and we also know the length of a base, and we know its height, that the area is still going to be base times height. Now, it's not as obvious when you look at the parallelogram, but in that video, we did a little manipulation of the area. We said, hey, let's take this little section right over here. So we took that little section right over there, and then we move it over to the right-hand side. And just like that, you see that as long as the base and the height is the same as this rectangle here, I'm able to construct the same rectangle by moving that area over. And that's why the area of this parallelogram is base times height. I didn't add or take away area. I just shifted area from the left-hand side to the right-hand side to show you that the area of that parallelogram was the same as this area of the rectangle. It's still going to be base times height. So hopefully that convinces you that the area of a parallelogram is base times height, because we're now going to use that to get the intuition for the area of a triangle. So let's look at some triangles here. So that is a triangle, and we're given the base and the height. And we're going to try to think about, well, what's this area? What's the area of this triangle going to be? And you can imagine it's going to be dependent on base and height. Well, to think about that, let me copy and paste this triangle. So let me copy and then let me paste it. And what I'm going to do is, so now I have two of the triangles. So this is now going to be twice the area. And I'm going to rotate it around. I'm going to rotate it around like that. Rotate it around like that. And then add it to the original area. And you see something very interesting is happening. I have now constructed a parallelogram. That has twice the area of our original triangle, because I have two of our original triangles right over here. You saw me do it. I copied and pasted it, and then I flipped it over and I constructed the parallelogram. Now, why is this interesting? Well, the area of the entire parallelogram is going to be the length of this base times this height. You also have the height written on the h upside down over here. It's going to be base times height. That's going to be for the parallelogram, for the entire, let me draw a parallelogram right over here. That's going to be the area of the entire parallelogram. So what would be the area of our original triangle? What would be the area of our original triangle? Well, we already saw that this area of the parallelogram, it's twice the area of our original triangle. So our original triangle is just going to have half the area. So this area right over here is going to be 1/2 the area of the parallelogram. 1/2 base, let me do those same colors. 1/2 base times height. 1/2 base times height. And you might say, okay, maybe it worked for this triangle, but I want to see it work for more triangles. And so to help you there, I've added another triangle right over here. You could view this as an obtuse triangle. This angle right over here is greater than 90 degrees. But I'm going to do the same trick. We have the base, and then we have the height. Here you can think of if you start at this point right over here, and if you drop a ball, the length that the ball goes, or if you had a string here to kind of get to the ground level, you could view this as the ground level right over there, that's going to be the height. It's not sitting in the triangle like we saw last time, but it's still the height of the triangle. If this was a building of some kind, you would say, well, this is the height. How far off the ground is it? Well, what's the area of this going to be? Well, you can imagine it's going to be 1/2 base times height. How do we feel good about that? Well, let's do the same magic here. So let me copy and paste this. So I'm going to copy and then paste it. Whoops, that didn't work. Let me copy and then paste it. And so I have two of these triangles now, but I'm going to flip this one over so that I can construct a parallelogram. So I'm going to flip it over and move it over here. I'm going to have to rotate it a little bit more. So I think you get the general idea. So now I've constructed a parallelogram that has twice the area of our original triangle. It has twice the area of our original triangle. And so if I talked about the area of the entire parallelogram, it would be base times the height of the parallelogram base times the height of the parallelogram. But if we're only talking about the area of, if we're only talking about this area right over here, which is our original triangle, it's going to be half the area of the parallelogram. So it's going to be 1/2 of that. So our area of our original triangle is 1/2 base times height. So hopefully that makes you feel pretty good about this formula that you will see in geometry, that area of a triangle is 1/2 base times height, while the area of a rectangle or a parallelogram is going to be base times height.